Given vector u equals negative 5i minus 3j, we're asked to find the magnitude, which is the length of the vector, as well as the direction, which is the angle in which the vector points measured counterclockwise from the positive x-axis, and we're told to give the angle theta in the interval from 0 to 2 pi radians. Let's begin by sketching the vector u in standard position, which means the initial point is at the origin, and then from here, because the x component is negative 5, we would move left 5 units. Because the y component is negative 3, we move down 3 units to the terminal point of vector u, which means vector u in standard position is this vector here. Notice by sketching the x and y components, we now have a right triangle on the coordinate plane that we can use to determine the magnitude of the vector, which is the length of the vector. Notice how this is the hypotenuse of the right triangle. We indicate magnitude using either single or double vertical bars. I will use double vertical bars. And then the angle theta, the direction of the vector, again, is the angle starting along the positive x-axis, rotating counterclockwise to the vector, which is this angle here. This is the direction angle for vector u. So going back to the magnitude of the vector, because it's the length of the hypotenuse, using the Pythagorean theorem, the magnitude of the vector is equal to the square root of the quantity x squared plus y squared. And then using the reference triangle for angle theta, tangent theta is equal to the ratio of the opposite side to the adjacent side, or we can say tangent theta is equal to y divided by x. Solving for theta, we have theta equals arctangent of y divided by x. But we do have to remember that the output or range of arctangent is the open interval from negative pi over 2 to positive pi over 2, and therefore the calculator is not going to give us this angle in the third quadrant, but it will give us the reference angle that will help us determine the angle in the third quadrant. Let's begin by determining the magnitude of vector u, which again is equal to the square root of the quantity x squared plus y squared, which in our case is equal to the square root of the quantity the square of negative 5 plus the square of negative 3. Simplifying, we have the square root of the quantity 25 plus 9. The magnitude of vector u is equal to the square root of 25 plus 9 is equal to 34. And now we need to see if the square of 34 will simplify, but determining if 34 contains any perfect square factors. Well, the prime factorization of 34 is 2 times 17, where both 2 and 17 are prime, and therefore this does not simplify, and we give the magnitude as the square root of 34. And let's determine the direction of the vector, which is our angle theta. Theta is equal to arctangent of the ratio of the opposite side to the adjacent side, or y divided by x, which is negative 3 divided by negative 5. Simplifying, we have arctangent of positive 3/5. And now we go back to the calculator. Let's verify we are in radian mode by pressing mode. Notice radian is highlighted, so we go back to the home screen and enter second tangent for inverse tangent, 3 divided by 5, close parenthesis, and enter. To 3 decimal places, we have 0.540 radians. But notice how this is not the angle we are looking for. This angle is in the first quadrant that has the same tangent function value of the angle we are looking for. So let's go ahead and write this down. Again, we have approximately 0.540 radians. So the angle that we just found is this angle here in the first quadrant that has the same tangent function value as our angle in the third quadrant. And because it has the same tangent function value, it must have the same reference angle, meaning this angle here must also be 0.540 radians. And therefore our angle theta is equal to pi radians plus 0.540 radians, which is the same as 0.540 plus pi radians. So going back to the calculator, instead of doing the entry here on the screen of 0.540 plus pi, if we add pi to the previous answer, we will have more accuracy. So I'm going to go ahead and press plus pi, enter. To 3 decimal places, we have 3.682 radians. Notice how if we added pi to this rounded value, we would not have as much accuracy. 0.540 plus pi is slightly different, but notice how to 3 decimal places, we would still have 3.682 radians. The direction of vector u is approximately 3.682 radians, which is the red angle here rotated from the positive x-axis to the vector, this angle here. I hope you found this helpful.